Welcome back to the channel. I haven't posted in a little bit. Today we're going to be learning about logic gates and Boolean algebra. A little bit about circuits. How they use logic gates, kind of their own formulas to get input and put back with their own formula. So basically, ones and zeros, false and true, and yeah, put. That's basically it. That is basically today. So yeah, basically turning inputs to outputs. Today we're going to be learning what Boolean means and its involvement in circuits and numerous logic gates and then formulas, basically turning inputs into their own outputs via the formulas. So yeah, that's basically today's lesson. It's very easy, it's very simple. Once we get into it, it's it's gonna get easier. So Boolean here means denoting a system of algebraic notation used to represent logical propositions by means of the binary digits 0 being false, 1 being true, especially in computing and electronics. Remember, 0 equals false, 1 equals true. I'm going to be using this here a lot. Please keep that in mind. I'm going to be talking back and forth between zeros and ones and false and trues. May get them confused. Don't worry. And yeah, these are especially used in computing and electronics because binary, it is the bare thing about computers. It is the absolute bare unit. Zeros and ones. They are everywhere. Your phones, your computers, your TVs, they're all using zeros and ones. They're all using binary. Everything with data has zeros and ones. Everything with memory, zeros and ones. And of course, there's a lot more than that. But that's basically the foundation of computing is binary. So today we're going to go over 7 basic logic gates, which will receive an input, produce an output. I should say will here. There's a lot of grammar mistakes incoming. Yeah, so these receive inputs, produce outputs. Very easy to understand. They get a number, they spit out a number back out, basically. They're like functions in a way. You know, like or linear line plus 7. That's a function. These are also technically functions too. We're gonna get into that. So yeah, 7 gates, and I even included pictures here, kind of like examples. So we got and this one, or all the way over here, not, and, nor, exclusive or, which is XOR, I guess. Say it that way, or XNOR, not and exclusive or. You can combine logic gates, which we'll get into here later. So we're gonna start off with our first example. You can tell this is gonna be fun. And this is gonna get harder as we go on. So an AND gate is a gate that only produces a true output if both inputs are true. Again, reminder 0 is false and 1 is true. Basically, a gate that only produces a 1 if both inputs are 1. And it is represented by the equation A times B, or your input 1 and your input 2. I'm making input 1 as A, 2 as B. You can see in this picture here, you got 2 inputs on the left. You got an output on the right, which goes into it. So, A, using this formula here, A times B, so 0 times 0. Anything multiplied by 0 is going to be 0, and we're pretty much going to be using that a lot. So 0. So yeah, so 0 times 1 is 0. 1 times 0 is 0, because anything multiplied by 0 is 0. 1 times 1, A times B, 1, 1. That is the only true function. Because that's the definition is, it only produces a true back out if both inputs are true. For the O gate here, apparently this is off the screen, but we're actually going to talk about this too. So if a stack overflow occurs, so that means if an output is more than 1, reverts back to a true 1. Because in binary, you cannot have anything that is more than 1 or less than 0. You can't have negatives. You can't have decimals. You can't have anything that is more than 1. You can only have true and false, 0 and 1. That is pretty much binary. You can only have zeros and ones. So, Stack Overflow is going to apply here, and I'm going to show you that here in a little bit. So the OR gate is a gate that produces a true and output if at least one of the inputs is a true, or at least one of the inputs is a 1. So A plus B represents the OR gate. So what is that? So 0 plus a 0, A plus B, 0. 0 plus 1, A and B, 1. Same thing for here. All going to be the same, things. I just put it there because I might as well switch them up a little bit. Yeah, 1 plus 1 is 2. But that's not the output because that's Stack Overflow. It flows. It's realistically called a buffer overload. I'm just going to call it a stack overload because it means the same thing. I mean, if you're going to look it up here just to show you. Stack Overflow in programming. Yeah, this. A stack overflow is a type of buffer overflow error that occurs when a computer program tries to use more memory space in the call stack that has been allocated to that stack. So, that's basically what it is. And for this instance, it goes back out to 1 because you can't have a 2. You can't have 2 trues. You can only have 1 binary. Again, yeah, look at it. Every single one of those that had at least a 1 or at least a true is true. That's an OR gate for it, pretty much. A not. Look at this little circle in the example here. The triangle is going to get cut out eventually once we combine multiple. The circle there is pretty much yeah, hold on, give me. Yeah. Look at that little gate. Pretty much any gate that has a circle there is not gate, or not gate. Is represented by A, which we're going to use as our one input. Yeah, this is one input, goes back to one output. A gate that reverts the input is the NOT gate, so the bar on top is basically reverting this A, reverting this variable. So let's say A is 0. So what's the opposite of 0 in binary? 1. That's true. The opposite of 1 in binary, 0. That's false. Pretty simple. Just revert your answer. We're going to go into more complicated ones with more than, one. And yeah, I accidentally did the first. Let's ignore that. So an XOR gate is an exclusive OR gate. A gate that produces a true and, which your true is an output here. If one and only one, if one of the inputs is a true. Yeah, this should be an only if. Only if one of the inputs is a true. This is represented by this equation. So the revert of A times B and parentheses plus start parentheses. A times the revert of B. I'm going to show you a calculator here because this is going to, get a little more complex as we go on. So let's start here. So what's the opposite of A here? 1. And then times 0 because that's regular B plus your regular A, 0, times a regular 0, but that's revert, so 1. It's still 0 because anything multiplied by 0 is 0. 0. If one and only one of the inputs is a true. Only one here. Okay, next up. 0 and 1 go to CE. So the opposite of 0 being a 1, so 1 times 1, that's B, plus A being 0. The opposite of 1 being 0 here. 0 plus the opposite of 0. The opposite of 1, 0. 8. You get it. It's still 1. This should have been a multiply, but it's still true. It means the same thing. Don't worry. This is the same thing for the next one. Same thing. The inputs are reversed. And then the opposite of 1 being 0 times 1 is 0 plus 1 times the opposite of 1 being 0, 0. So that's still false, even though both inputs are true. And in a regular OR gate, it only requires at least one input being true. An exclusive OR, it must be either or. It has to be at least one true and one true only. Or else it's going to be false. Starting off here, we're going to combine NOT gates and other gates. Like, for example, and, an OR, an exclusive OR, which we went through already. So everything's going to pretty much be the opposite. So an AND gate is a gate that only produces a true if both inputs. A NAND gate is the exact opposite of that because it's a NOT gate. A NOT gate pretty much reverts any output you get out of that. So the NAND gate is a gate that only produces a true. Both inputs are false. Again, a regular AND gate would be if both inputs are the opposite. Again, these bars over here represent reverts. The opposites, binary. So 0 times a 0, well, what's that in reverse? 1 times a 1, so 1. True. A 0 times a 1. Flip that around because again, the 1 times 0, false. A 1 times a 0, revert that, 0 times a 1, so 0, false. And a 1 times a 1, both opposites, 0 times 0 is only if both inputs are false. A NOR gate. So again, a regular OR gate is if at least one of the inputs is true. And yeah, again, you can have Stack Overflow here. It's going to be the same thing. XNOR, a NOR gate, went onto the wrong slide. Yeah, so if at least one of the inputs is false, so the exact opposite. So the revert of A plus the revert of B. So again, what's the revert of 0? 1. The other one being 0. The revert of that is 1. So this is 2. Again, Stack Overflow. Can't have that. You cannot have a buffer overflow either. Oh, here. So it reverts back to a 1. If one of the inputs is at least a false, this would actually be true, but let's go over it. A 0 plus a 1, revert of that, 1 plus a 0, 1. Then, the opposite, 1 plus 0, 0 plus 1. And the exact opposite of that, plus 1, 0 plus 0, 0. So that's false. So at least it requires one false gate to make, one false input to make all of that true. An exclusive NOR gate. This one's a little different. As we did before, the exclusive OR, the regular one, is if one and only one if the inputs are true. Everything's the complete opposite here. So it's not just if one and only one, it can be if both inputs are the same. Not only if, it's only if not one, but two are the exact same. Basically meaning both inputs are the same. And before I overgo this formula here, you notice like the NAND gate, the AND, the OR, the NOR, and the NOT gate, combining with those, it makes the formulas the opposite or the revert of the equation entirely. Not the operator, but still, you get what I mean. It reverts the values, either from 0, 1 to 1 and 0, basically reverting true and false, right? And then, yeah, for this one here, the formula is the revert of A times a B plus A times the revert of B, it would still be equal to this, even though, yes, you could make this B a revert and make this A revert, and that would be cool. It basically means the same thing here when you work out the equation. So it means the exact same thing. Okay, yeah. A gate that produces a true if both inputs are the same. So we already can tell what this is. But we're still going to work through it because Boolean algebra. Okay. So 0 times 0, 1 times a 1. That's 1 already. And a 0 times 0. So what's 1 plus 0? 1. So the 0, you have revert of that 1 times the revert of 1, 0. So 1 times 0 plus 0 times 1 is 0. Because anything multiplied by 0 is 0. And I'll even show you an example here in text, just to show you, just to make sure I'm not losing my mind. So, the revert of that, and I'm going to do it here in an example, basically means the same thing here. Second, though, and put the line, just to show you guys what I'm trying to talk about. So the opposite of this is which is still 0 because anything multiplied by 0 is 0. So, yeah, same thing here, because if you do the opposite, just kind of just do the same thing, do the same. The 1 times 1, got rid of that. The revert is 0 times 0, then plus 1 times 0. It's actually just 1 times 1. I don't know why is it. Okay, yeah, revert that. The revert of this, 0 times 0, 1 times 1, 0 plus 1, 1. That's true. That's pretty much all the basic gates. That's pretty much all of it, to be honest. It's pretty easy. If you have these formulas, it is pretty easy. Now, what do you have more than 2 inputs? More than just an A and a B? Well, let's say this one has 4 outputs. This one's an AND gate because, shape is an AND. What do? You can add more than one variable. And I'll even show you an example of how this works. So let's say A is 1, B is 0, C is 0, and D is 0. Well, that's going to be 0. Again, anything multiplied by 0 is 0. And since an AND gate requires all inputs pretty much here, not just both, but all inputs to be 1, all inputs to be true. But since a lot of these are false, false. Pretty simple. Let's go over this OR example. This one has 9 pins. 9, yeah. I think it has 9. A, B, C, E, F, H. So this one's going to be an OR gate, which, says if at least one of the inputs is a true. And I accidentally put multiplication here, but let's pretend these are additions because this is an OR gate. So let's say A is 1, B is 0, C is 1, and everything else is 0, except I. Because let's say that equals to 3. But since, again, stack overflow, you have more than 1, it's 1, which still makes the statement true. Let's go over an AND, not AND. Only both inputs are false. Basically, it has to be all inputs being. So let's say what? This is also 9, 8. This is 8. So 0 times 0 times 0 times 0 times 0 times 0. And it has to be the opposite here. So let me get this line from this slide. It has to be all this being the same thing. Basically, these all turns to 1s, and once you multiply all of that out, is because all these zeros turn to 1. 1 times 1, anything 1 times 1 on times 1 times 1 times 1 is still going to be 1. And let's go over our final example of today here, a NOR gate. This one has 5 pins, or 5 inputs, I should say, not really pins. I just say pins because I'm a robotics guy. This is robotics too. This one's a little different because a gate that produces a true if at least one of the inputs is false. So A plus a B. What's the opposite of that? So A plus B plus C plus D plus E. The opposite of all that. Right? That. And it states that a gate that produces a true if at least one of the inputs is false. So basically, let's say 1 plus 1 plus 1, 1, which all of that is the exact opposite. So 0, 0, 0, 0, 0, 0, 0 being 0. Then plus 0 plus 0 has to be at least 1. 0. 0, 0, 0, 0, 0, 0, 0. That turns into 1. 1 plus 1 plus 1 plus 1. That's actually 5, but again, that overflow can't have more than 1. Turns to 1. Or at least a 1. And yeah, that's basically what you do with multiple input gates. You just add an extra variable. Depending on how many inputs you got, you just add more and more until you got the right number. And still follow the rules, pretty much. An AND gate, if both inputs, what do I mean both inputs? I mean all inputs. Doesn't matter if like at least one, it's still at least one. An exclusive gate is going to be interesting. This is just basic, okay? Maybe the next day I'll go over multiple input like exclusive or exclusive not or even exclusive or and not exclusive or. Maybe I'll do that next time. But no, this is just an example of and, not and, or, not or. And yeah, that's basically Boolean algebra. Just 0 equals false, 1 equals true. All these gates and all these formulas. Pretty easy. Thank you for watching, and see you tomorrow probably.